I know that you're interested in using AI to tackle climate change.
Yeah.
So we have actually done an episode on AI being used to tackle climate change. So listeners can listen to episode 459 for kind of like an hour on that topic. But something specific to that for you is that these huge models like GPT-3, for every additional model parameter, there's a little bit more energy that's required.
Yeah.
But when we're talking about hundreds of billions or trillions of model parameters to train these models on large data sets, and then even at inference time, the impact in terms of climate change is non-negligible,
Yeah.
especially as these potentially become more and more popular. So AI is increasingly a contributor to carbon emissions. On the flip side of that, insights from AI could be providing solutions to the climate crisis.
Yeah.
So, what do you think about this in general? How can we mitigate issues around these large models generating emissions, and then what are the more promising AI-driven solutions to climate change?
Yeah, that's a great question and a big issue. And yeah, I think there's kind of thinking about it at training time, thinking about it at inference time, as you mentioned, and then also how this whole ecosystem kind of also connects to sort of general access to models. And I think with the training, there's the good news is that typically as we go forward, compute gets more efficient, cheaper. And so what something looks like right now, 10 years from now, it's not going to consume the same energy to train that system. But we're also probably going to have bigger systems. So that's kind of a tricky situation. So I think that's one issue. And I think the biggest thing there that's really helpful is having renewable energy drive a lot of these, the cloud services that are actually powering these systems. So like Google is doing a great job of moving a lot of their compute in a really good direction in terms of renewables. And I think that's something I hope we can be really successful with that in the next kind of 10 years. In terms of inference time, I think so a lot of these models are actually much more efficient to run at inference time. So once you've trained it and you're querying it for different outputs, that can be pretty efficient. And you also can engineer the system in a different way so that it's actually running very quickly and in a very efficient way at that point versus how you trained it. So I think that's another thing that we can do is like separating out those two use cases so that you are making it as efficient as possible when you're running it into the future. And the last thing is thinking about how this affects kind of democratization of AI and access, because I think something we talk about is like there is this issue where only a few groups have the resources to train models like this, and then they have kind of the dominant access to those systems. And so in some ways you might say, oh, ideally like everyone could train systems like this, but then suddenly we're replicating these hugely compute intensive models across many different groups, and that becomes very wasteful of energy. So I think it's going to be really important to move towards some sort of coordinated system where we can both only train a model once and then let everyone use it, but we're not kind of like hoarding access so that some people are totally shut out from something. And I think that's a really hard line to walk. Like we want people to be able to research these systems, use these systems, but we also don't want to kind of overly replicate things that are very resource intensive. So that's something I think about a lot. I think then going into ways that AI can help with climate change, I think two things I'm really excited about are energy efficiency and kind of thinking about intelligent grid systems and just intelligent use of electricity. And I think that will also help with incorporating renewables better. If we have a better understanding of forecasting and how to integrate all these systems, it could save a lot of waste within our energy grid. So that's one thing I'm excited about. And then also thinking about the materials discovery space. So using AI can kind of speed up discovery in a bunch of different scientific areas by speeding up simulations that people run to sort of figure out what might be promising directions to explore.
Right.
And I think we're starting to see applications like this used in carbon capture or battery technology or things like that that are going to help us have, again, like more sustainable systems across the board.
Very cool examples. So we'll ask GPT-6, draw us a schematic of how we should design the tokamak reactor for a fusion, nuclear fusion energy production that exceeds the amount of energy we put in.
Perfect.
Nice. It'll be easy. So it's really just a natural language problem.
Yeah, when you put it that way.